All right, so we talked the other day about vertex form. So that was yesterday. I don't know why it felt like it was like 4 days ago, but we'll go with it. So vertex form of a quadratic is a y equals ax minus h squared plus a k. Okay, and some people said that had looked familiar from last year. So let's just do a quick review of what we were going over yesterday, and then we're going to build on it with some different types of problems. Things like finding zeros and then writing equations given certain information. So if I give you this equation, or any equation, oh my gosh, it's a Sherman. I'm losing my mind today. Okay. So there's usually like certain questions we ask about things in vertex form. The first of which is usually, what is the vertex? Okay, so that was usually hopefully not a bad one. That's why I like vertex form. The information is all just kind of right there. So it's h comma k. Just remember with the h, be careful because that minus comes from the equation. So the h is positive 4. So please don't write negative 4 or always remind yourself it's the opposite sign when it's in the parentheses. And the k is negative 2. Okay, so that's pretty not bad to label. Usually next we ask for the axis of symmetry. The axis of symmetry is always going to be an equation. And the equation is always x equals, and then it's just whatever the x from the vertex is. Now, as I'm filling in information, I'm just going to kind of start my graph. So we want to be comfortable with graphing as well.
What happened to my eyes?
Oh, I don't know what did happen to you.
I cannot see.
Oh.
Like at all.
Do you need to move?
Yeah. I have my contacts in.
Oh.
I can't see anything.
Okay, feel free to move.
Maybe you need a strong prescription. I'm so confused right now. Like I can't see anything. Do I need a wipe or can I just move up here and wipe it down?
I don't think anyone's sat there the whole day. So you should.
I'm so confused.
Hi, welcome to the front row. Why do I? Oh my God, is this the exact problem we did yesterday?
I wasn't paying attention yesterday. You want me to be
Can someone tell me?
Yeah, it is.
I'm like, dude, why is this problem so familiar? Sorry, guys. You could just write that info down. I'm going to do another problem. What a dip. One of these days, my brain will grow back. I was doing it and I'm like, dude, I know I've done this problem multiple times before, and it's because I did it twice yesterday. No wonder. I have to do the one under that bag. Okay, sorry, same idea. What's the vertex? Okay, the vertex of this one, just be careful. Since that's a +1, it changed that sign. The x is actually -1, right? Or always remember to do the opposite sign, and then 4. Oh gosh, axis of symmetry. Once again, it's always going to be a vertical line. We'll draw it in a second. And it's always going to be the equation x equals with the x coming from the vertex. I knew when I started to run that side that didn't make sense. Because we should be going through the point -1, 4. So I'm going to start with that point. That's my vertex. Through that is the axis of symmetry, which is just kind of a vertical line. It's just I always kind of think of it as like the mirror. It's the thing that's going to reflect over and make our parabola symmetric. Next thing, or at some point you're usually asked, is that vertex a maximum or a minimum? And we know that we can, well, one, you could graph it, but you know that just by looking at the equation, looking at A. So this number in front. If that number is negative, it means it flips it, the U upside down. So we would say this would be a maximum because it opens down. So it would be at the top of the U. And then, other things we always kind of bring up randomly is domain. The domain for these, there's no restrictions. You can kind of plug them whenever you please. So it's just all real numbers. And then the range, I'm going to graph it so we can kind of just visualize it. So let's graph first and then we'll go back for the range. So I need to find a few points because right now I just have a lonely old point there in the middle and that's not really helping me visualize what's going on. So I usually make a little chart just to organize myself because I need a few points. I remind myself that my vertex should be kind of in the middle of those points because I want a few to the left and a few to the right. So if my x is -1, I'm just going to choose some x's around it. So I choose usually 2 to the left and 2 to the right. So I'm going to do -2, -3, and then on the right I'll do 0 and 1. So what I do is I take each of these individual x's and plug them back into the original equation. So just in my calculator, I do -2, parentheses. I'm going to do -3 plus 1, square that, and then plus 4. And I get -4. So I kind of just keep doing that same step, just changing my x that I'm plugging in. I like to do it like this. Technically, you really only need 2 points, but I like to plug in those other points kind of just to check myself. Actually, last period, I totally made a mistake, and this is how I knew. Because these points should reflect across the vertex, and the same thing should happen for the next one. It should be a reflection of that. So that's always a good way to just check that you're good with plugging your points in and your points make sense for your parabola. And then from there, you just kind of plot them. So -3, -4 will be down here. -2, 2. And then the other ones, once again, they're just reflections. So they just reflect across. This reflects over here. And then we have our nice, in this case, parabola that is opening down. What a beauty. When we say the range, I just like to visualize it. We always say y. In this case, since our vertex is a maximum, everything is below it. So everything is less than or equal to. And it's the y of this point, which remember is just the y of the vertex, so that would be 4. So those are usually the major things. You don't, when we eventually are trying some, you don't necessarily graph every problem because that gets kind of old. So sometimes it might just ask you to label some specific things. So the graph is nice for a visual, but the labeling should be able to be done without the graph. So just as a heads up there. Sorry, I started the wrong problem. Are there any questions in general with just labeling from vertex form or being able to actually graph it? Okay. Hey guys, oh, you can't see them. Hey guys, did you see my new curtains?
Yes.
Aren't they so nice? And then you guys will see them. Look at how crafty I was. I know how the sun, changes angles. So I was thinking, how to do look.
Oh, that's cool.
Oh my god.
Wasn't I so smart?
That is very smart.
So like when the sun's high, I'm like, oh, I get it.
That is very
I'm
cool.
like so proud. This is like my proudest moment.
That was such a good idea.
I know. Like you're telling me. I'm really proud. I'll show you guys something. Because it's so like the sun just like layers in the rooms on the side. So now it'll be nice and cool when it's the summer. Well, not summer, but keep the heat out. Sun.
I do not know why I cannot see right now. I'm so confused.
Maybe you just, I don't know. I don't wear contacts, so I don't understand them. But sometimes my husband's like, I just need new contacts. Does that
Yeah, maybe I
happen?
need to change them. I don't know. I cannot read like.
Because that happens to him like all the time. I'm like, what? I can't see. Don't drive with eye contact. Okay. So we have a general idea, vertex form, woo. So the next thing we want to do is we want to be able to find zeros. You're probably saying zeros of what? Zeros are just x-intercepts. So it's just a fancy word. If I ever say find the zeros of a function, I'm just asking for the x-intercepts. We've actually been finding zeros basically for the past few weeks because anytime you solve a quadratic equation, you're actually finding the zeros. You're solving for x, and that's the x-intercept. So the nice thing is that's why we do solving first. We kind of have an idea of how to do this. But just as a reminder, relating it back to graphs, if I think about any graph and I think about any x-intercept, anything on this x-axis, what always happens to the y? The y is always, if I'm on this line, the y is always 0, okay? And that's the main thing you need to know about an x-intercept. Sorry, my mask is killing me today. If a point is on the x-axis, Sorry, I know I'm kind of in the way. I will move in a moment. The y is always 0. So, to find an x-intercept, we're going to plug 0 in for y, and then solve. Okay, so let's say I give you this equation. And I say, oh, we have this nice little equation. We could find all other stuff, right? We could find the vertex, we could find the axis of symmetry, we could find the domain, the range, whether it's a max or a min. We can do all that by just by looking at it. But one thing I could also ask is, can you find the zeros, or can you find the x-intercept? So to do so, all you would do is say, well, if it's an x-intercept, the y is 0. So I'm going to replace this with a 0. And I'm going to solve it. Hey, we have a lot of ways to solve. We have factoring, we have square roots, we have completing the square, and we have quadratic formula. Can anyone take a gander? What would be the best method to solve this problem?
Do x minus 1 squared first. Or
You could do that. It's going to be kind of a pain though, because you would have to do x minus 1 times x minus 1. You'd have to distribute that. Then you'd have to distribute a negative 2 in. Then you'd have to add a t. And then you finally have an equation set equal to 0. And then you'd either have to factor it, do completing the square or quadratic formula.
If you divide both sides by negative 2 and then get rid of the squared by doing the square root.
Square root. So I'm going to show you square roots, I think. You can do the other methods. Once again, that's the thing about quadratics. You can set it up how you please and kind of go from there. But once I see that this squared, this lends itself to using square roots. So that will be my hint. So before we start, I'm actually going to subtract that 18 first. So I'm going to move the constant. Okay, so now that's moved. Once again, I still want to isolate that parentheses. I'm going to divide everything by negative 2. Please don't distribute in. You can't distribute when that's squared. That's illegal. So I'm just going to kind of write over here because I'm running out of room.
Can you say the answer is 4 if I actually did this right?
Oh my gosh, I don't know. We get 9 equals x minus 1 squared. We're going to take the square root, because once again, that gets rid of the square for us.
I'm going to be so excited.
Please make sure when you take a square root and you're solving, you need the plus or minus. And thankfully, that was a nice perfect square. And then we'll move this constant over here. So it comes out to 1 plus or minus 3. And if we can combine things, we combine them. So we don't leave our answer like that since these are both rational. We'll do 1 plus 3 and 1 minus 3 to get our two answers of x equals 4 and x equals negative 2. Is that what you do? You do know what you're doing, see?
This is so surprising.
Oh, very good. I'm not surprised.
This is a shock to me.
It's a good job. So, the nice thing about that is there's nothing really new about it, okay? We could throw a 0 in there. I feel like we've done that before for certain problems anyways. And just make sure you're comfortable with solving. But once again, the vertex form, it's always going to kind of start like this. I mean, the numbers might be a little bit different, but that's going to be that setup. So I tend to use square roots just because it lends itself to that thing being squared. Are there any questions on that problem? So I'm going to have you guys try one. This one's going to have a little more simplifying to it. Things like, because when we think about intercepts, they don't always have to be rational, like 4 and negative 2. You can have something go through 7 root 3 or 1 plus or minus 2 root 29. Not everything's perfect, unfortunately. So you can have irrational answers. This one's going to be irrational. So if I gave you this equation in vertex form, can you please find the zeros of that equation? So I'm going to give you guys a minute to try that. And I'm just going to do attendance as you're doing it.
Am I allowed to use my phone calculator?
Alright, let me see what's here. Alright, I'll give you one more minute. Hopefully that shouldn't have taken too long, but there was a little bit more simplifying with that one compared to the other one, which had a perfect square. All right, let's look at it. Let's see how much people listen here. So you guys are on the same pace. So same idea. If I want to find a zero, I put a zero in for y, and I'm going to solve for x. So I'm going to start by adding 5 to both sides. So I'm going to add the 5. I'm getting lazy, so I'm not going to write my steps. To this side, okay, there we go. I'm going to divide both sides by 3. And I get 5/3 equals x plus 1 squared. Okay, so that looks pretty similar to the last problem. I am going to take the square root. So this one, I said there was a little more simplifying because now we do have the square root of a fraction. So that gives me plus or minus. When I have the square root of a fraction, I'm going to do the square root of the numerator over the square root of the denominator. And then we do what we call rationalize it. So I don't want a radical on the bottom, so I'm going to multiply by root 3 over root 3 to take care of that. And that's going to give me plus or minus root 15 over 3. Okay. So I'm just going to rewrite plus or minus root 15 over 3, now that that's simplified, equals x plus 1. Because when I took that square root, it canceled that. And then I'll subtract that 1. Move that constant. To get my final answer is x equals -1 plus or minus root 15 over 3. You can leave it like that. If you wanted to make a one big long fraction over 3, you could do that as well. I usually just tend to leave it. Why not? I can't simplify anymore because that radical doesn't break down, and you can't combine those because one's rational and one's irrational. So there you go. So that one had a little bit more simplifying, same general idea though, with the solving using square roots. So at the current moment, are there any questions on this stuff? Okay, so there's only one other type of problem we'll do. So I'll show you that. It's pretty quick. It's just kind of plugging stuff in. And then I think I have like 2 wrap-up problems just to make sure you have some practice and you can ask any questions if you got them. And then we'll wrap it up. So, what do we do? Oh, I need my paper because I don't have my numbers here. You never want me making up problems because I'll make them all sorts of messy. So I'm just going to say write an equation in vertex form. Okay, we can do that. We know vertex form, but we're going to be given some different information. We're going to say that we're given the vertex. Okay, that's delightful. And I'm also going to be given a point. So So my main goal is okay. I don't know what the heck to do. So just, if you never know where to start, just label what you have. A vertex, I know two things. I know H and K. Alright, so it's really just a special point, because it's the middle of the thing. A point is just, a regular point. We label that X and Y. So when we think about vertex form, I have H and K. I have X and Y. The only thing I don't know is A. So on these problems, your main goal in the end, when I say write an equation, I really need to find A. That's the main goal. Because once I have A, I can go back and write the equation. So let's plug in what we know. For this specific point, we have 5 equals A, parentheses, X minus H, excuse me, I just said H, but I meant to say 2. 3 minus 2 squared minus 1. So we can solve for one variable, no problem. We just have a little bit of simplifying on that right side. 3 minus 2 is 1. 1 squared is 1. And I can solve for A by isolating it, where A is going to equal 6. Okay. So I plugged in HK, XY. My main goal is to find A, to solve for A. So once I plug those numbers in, I just did a little bit of simplifying and ended up with A. That is not your final answer. Your final answer is an equation. So that's the big thing. So to write an equation, I know we have this point, and that's exciting, and that helped us, but we don't write this specific point in the equation because we know our parabola has multiple points, has infinite points because the parabola goes on forever. So the point helped us, but we don't write it in the equation. We just take into account H, K, and A.
Why can't we write that one in the equation?
Because
it works, right?
Yeah. It's just because if you, hold on, let me write it. I can't write and talk at the same time. Hold on.
Right.
X minus 2 squared minus 1. Sorry. 1, if I put 3 and 5 here, that's like not even an equation. That's just a bunch of numbers written, right? So we always need X and Y to stay as X and Y so I can find other points.
Oh, okay, yeah.
So that's just one point, which is great, but we know parabola has infinite number of points. So then that allows us to find other
Yeah, because now
points.
this is an equation.
Exactly.
Yeah.
So equations, you always keep X and Y as variables, so you can plug into it or find stuff from it. So that's that. That's as crazy as that one gets. It's just taking the information and knowing what to do with it and going from there. So basically, that's all the stuff we need with the vertex form. We should be able to label from vertex form, like things like what's the vertex, axis of symmetry. I should be able to graph it, domain, range, max, min. I should be able to find the zeros, which sometimes is helpful with graphing as well. And then in this one, we were just given some information and we wanted to write it in vertex form. So we just plugged in what we knew and found what we didn't know. So any questions at the moment? All right, I'm going to give you kind of 2 problems to try just to make sure we're good before we move on. And then I have one other thing that I wanted to talk to you about. So that will take about 2 seconds. So actually, I'm just going to stop. Well, you might not be saying yes in like 3 seconds, but it's okay. All right. Hold on, I'm going to.